Yeah, they are broken.
Okay, Eric, we are filming.
Another thing is, I'm not
David, can you be a camera guy? Thank you.
I can be
the amount of times I'll be here is going to be significant.
My English Sophie.
Okay.
Okay, and we are recording.
Okie dokie. So for my project, well, I guess it kind of all started when Mrs. Scanlon from the Eco-Action team proposed an idea that I create this box that essentially controlled pump, like this water pump, as well as collected sensors for her hydroponic tower that she was creating. So I started last year, and this has kind of been a culmination over many, or I guess a couple of years, on trying to create the system that would communicate over the internet. So some of the core, I guess, facets that I kind of need to learn and understand when I was creating this project was like just the kind of the general idea of industrial design, making it easy to use, making it rugged, making it waterproof. So like as you can see, it just has this easy like waterproof housing, and all the connections are standardized. They all use the RJ45 connector, so it's all standardized, all interchangeable. And also, a few other things that I learned was just the idea of taking your projects out of a lab setting and putting them into the real world. So, for example, like if something I had a big problem was I controlled all my motors, or the relay for the motor, originally using this system called Millis. It essentially just tracked how long the Arduino had been alive, just in millis, I guess, yeah. So, but part of the problem was they used, I believe it was a unsigned long, and that would, if you do the math out, it would essentially overflow in 50 days. So essentially that meant that eventually the way my code was set up, it would eventually miscalculate, and it would either flood or it would give a drought for these plants that I was trying to work with. So for that, I kind of had to overcome some things. I no longer really use millis anymore. I use some other things. And another thing I kind of had to do was create, or essentially put in an uninterruptible power supply. This is another part of the industrial design. So if the power goes out, this is an experiment that people are doing. So you have to have a battery backup, and it's also going to send people information that the power is out. So it has to be able to continue running and give water to the plants at the very least. So can you scroll down a little bit?
Oh, sure. How long can your UPS last? Like, can you operate valves and stuff like that for days?
So it depends on, so it's actually giving all the power to the pump. So the whole entire system runs off the UPS if the power is out. So it's like, it depends on the cycle, so how often you actually want it on, because all the power is going to be at once on, and really not very much power once off. Okay. So it's like 1 to 2 days, depending on what your settings are. So another part of my project was that it was proposed that you should be able to have more and more sensors in the future if they need it for the experiment or whatever. And obviously, I'll be gone in a couple months. So I kind of came up with this idea while I was trying to figure out how to integrate sensors without them changing my kind of complex code. So what I did was I took a smaller Arduino. It's called Arduino Pro Mini. It's a really cheap one, really cheap chip that's like that big, and it's really small. I can show it to you. I have to set it on. I'm not gonna show it to you. So essentially, it isolates their code. Not that there's anything wrong with the code, but it isolates their code from my code using I2C, and it essentially allows them to explore and experiment while the integrity of my code still is good, I guess. So talking about I2C, so essentially it's communication, it's a serial communication over 2 wires. The nice thing about it is that it's kind of a generally accepted communication format. The temperature sensor and humidity sensor ran I2C default. I could configure the pH sensor to do it. And for Arduino, it's not so hard to program that all up. So that's why I use I2C. It's very simple. Oh, it's very, very clean. To control these 4 sensors, I only use 4 wires, and 2 of those are power and 2 of those are data. So that's kind of nice. part of my project was trying to make it as easy to use as possible, and I have on this one, but I make two. So for example, I have these QR codes essentially that allows people that maybe aren't as savvy as I am to just scan it, and I'll have YouTube videos online that talk about how you might go and program the accessory port or the general maintenance and see, make sure troubleshooting is all right. For engineers, people that might want to be interested in the way it's designed, you can see I put some waterproof putty around here so it all sealed up. So maybe people that are interested in that, maybe the electronics part of it. And for researchers, so online, unfortunately I don't have either of these up and running, but online it's a great GUI, and it pretty much allows you to upload and offload all the data that you'd like in real time. So yeah. Any questions?
Good job. So where's your data being stored? Are you using Firebase?
So I use.
You don't like Firebase? No.
I'm not really. So originally, when I first started this project, I was doing it on an SD card, and all the data was on the SD card. And I was gonna keep it that way as well as update it to the internet. So I'm not in control of the data server. I essentially just send. It's this really nice data hosting server. I essentially send it values, and it'll graph it in real time, do stuff like that, and allow me to send values back to here over the internet. So I don't have to pay anything. And
so you have Wi-Fi on there, basically.
I have Ethernet. So these.
Okay.
I kind of indicated it. So I have this Ethernet shield for the Arduino, and it just allows you to put Ethernet out.
So as long as you plug it into valid Ethernet, it will upload.
That's kind of
cool.
the reason I choose Ethernet over Wi-Fi is that most of the time, at least, or almost always, there's no authentication. So that kind of makes it.
So like plug and play.
Yeah, it makes it plug and play.
What about how does I2C figure out which sensor it's communicating with?
Okay, so
that has to be a huge advance that you had to research.
So the way it decides is that there's these channels here. You can choose up to 1,024 channels that you can choose for this. So, for example, my accessory port's on channel 1, the pH sensor's on channel 99, and the temperature and humidity sensor are a little more complex than that. They also have these things called addresses, which kind of specifies not only what device, but what data point you want inside that device. So it gets a little more complex, but that's generally the way it works. So it really adds expandability. In the future, I'm going to have. So the kind of problem with that is that the code inside here needs to know what numbers to look for. So that kind of makes it more select. Either you have to run through every single number and try to figure out which one's available, or you have to know.
Right.
So in the future, there's another kind of weird system that they use that it assumes that there's only 2 devices on a particular set of wires. So it doesn't matter what connects up; it will always have serial communication. So I'm thinking about changing that. It would add a lot more wires, but it would make it truly plug and play for any device that you want.
Very cool. All right, thank you.